So 6.2, factor by grouping. And this works a little bit differently, but the concept of being able to change things to fit what you want is very crucial in this section, okay? Well, if it's not, then it will definitely be in 1010. It's possible we may be using the rule for this section, but just so you understand, if we are doing this factoring by grouping by hand stuff, you have to be able to understand that it's possible to take something like a 10x and split it into like a 2x and a 5x. Like this. That is the same. What I have there in red is the same thing that what I have in black. It's just for factoring, generally speaking, we do want to split it up into other ways. Okay, maybe it'd even be like a 9 and a 1. I don't know. It just depends. So yeah, factoring is the reverse of distribution, and factoring is so fun. Factoring by grouping. The largest common factor is sometimes a binomial, which we saw in that last problem, right, of 6.1. After, in order to identify a common binomial factor, we must regroup into two terms of 2 terms each. Yeah, that was like what we saw, 2 terms of 2 terms each. That's what we saw in that last one, right? Was it b minus 4, and what was the other one? Yeah, that's what we saw in that last problem, right? So that's 2 binomials being added together. It's 4 terms total. I mean, in separately, but technically you could say that this is 1 term all by itself, okay? But this is kind of how we're going to expect our answers to look like when we start to factor by grouping. So just like that last problem that we saw in 6.1, right here in this one, I see this x minus 4 in this term, and then we also have the same x minus 4 in this term. Boom, that means I can factor that out. Okay, so I'm going to pull it out, x minus 4. And then what do I have left on the inside here? Well, the first term there had a 2 that was left over, so it stays. And then the second term there was a positive 3y. So I bring that down, positive 3y. All right? That's all we're going for on this. Now, like I said before, it'll take a little bit of work. If they give us a quadratic or a trinomial, really, then it may take a little bit of work to get to this point, but we can get there. Oh, yeah, here we go. Here we go again. Yeah, another one like this. Like I said, I kind of like these because they're kind of already set up for us, but you got to be careful, actually, because we got to look at those first 2 terms. So it's okay to factor out our x plus 5s, because I think that's kind of the obvious part right here. And I didn't do this on the last one because there's an extra step that we're going to have to take on this, okay? But yeah, that means I'm going to factor out this x plus 5. Now we got to look at what's left of our binomial. Right? For example, we got the 3x. That's our first term. And then we have the positive 6y. Now, when you get to this point, those last 2, I kind of skipped this part really just to save time because we got another section to go over. But what we need to do actually is look at these 2 terms. Even you could look at these 2 and see if there's any greatest common factors in there that you could factor out. You could have done it back here as well, other than the x plus 5, but you definitely have to do it right here, okay? So here's what I'm talking about, is we got to look at the 3x and look at its prime factorization. Well, that would just be 3 times x. I'm just looking for a greatest common factor, that's all. And then we also look at the 6y, and that would break up, the 6 breaks up into 2 and 3. Prime factors, right? So that's 2 times 3 times y. And then we need a greatest common factor. Well, it just pulls out as the 3 here. Excuse me. Okay. So from the black set of parentheses, and I guess I want to put it on the right side. I hope that's okay. All right, so we didn't do anything with the x plus 5. It's still there as a factor. But what do we have left from the purple? We got the x, that's our first term. And then the second term has a 2 and a y, so that'd be positive 2y right there. We have to be able to factor out that 3 right there, at least if you want full credit. Now, the other ones that we've seen, you can look back, but there was no common factors within the other set of parentheses to factor out. If there was, then we would look to do it, but This is the first time we've seen this. So always be checking though. Okay, always be checking to see if there's any common factors in either set of parentheses that you can pull out. Now, generally speaking, they would want that 3 out in front. I really don't care. And then, like I said, the order doesn't really matter because of the commutative property of multiplication, but I guess this kind of cleans it up too. There we go. This one's just the cleaner version. It's a good question. Technically, in the beginning, the x plus 5 was only one of the factors of the greatest common factor. The other one would have been the 3 that we yanked out as well. So if it did ask, like on this problem, if it asked for the greatest common factor, I don't think it will, but it's possible that it may. It's this. So what you're saying is true. The 3 is part of the greatest common factor, but it may not be so obvious that you have to pull that out in the beginning. All right, so here we go. We got 4 terms now, right? So I would be looking to kind of split this up. And, I mean, you could switch the order up if you needed to make this easier for you, all right? But, yeah, write an equivalence by factoring out the greatest common factor. Okay, so what's the greatest common factor here? Now, you can look at each individual term, right? Like x to the power of 2. In fact, let's look at those, right? So that's x times x. And then 3 times x would just be, well, 3 times x because it's 3 is already a prime number. 2 times x, and then 6, you could say, is 3 times 2. Now, the problem with this, and I am doing this purposely differently because I need the space, but you see that there's no common factors in all 4 terms. It has to be all 4 terms, okay? This is where we look to group factor by grouping, okay? Meaning that what I would like to do here is take this first group of 2 and factor that, and I would be looking to factor with the second group as well. Now, this plus right here is pretty crucial. If it was a minus, then I'd just make that a -2, okay? It's not, so I don't have to worry about that. So all I'm doing now is looking to see through each of these 2 binomials now. I force them to be binomials, which I am allowed to do. Putting the parentheses here does not change anything. It just changes the way it looks, okay? So I'm looking for any common factors that I can yank out from first, x squared and 3x. And I see, just from the factors that I have written there, there's already the x's in common, so I'm going to yank those out, okay? So what do I have left over on the inside? The first term, there's the x left over, so that's my first term there. And then the second term in purple there is just the 3. That's positive 3. Now, seeing this x plus 3 right here, you're going to have a little bit of deja vu here in a second because it's going to come again. It should, by the way, because just like we saw in the last 2 problems, we're looking to essentially factor out, from factoring by grouping, we're looking to factor out a binomial, okay? So what do we got in the second set? Well, from that set, I can factor out, see these 2's that are common? I'll do that a little better, hopefully. These 2's in common, so I'm going to factor out a positive 2. So what do we got left? In the green term, I got the x that's left over, the first one. And then that second term, we got the 3 that's left over. It's positive, okay? See how these, oh, I guess I could have color-coded those to match, but they match. X plus 3, X plus 3. There. Now it's exactly the same type of problem that we just barely saw, where I can now factor out the common factors of x plus 3. Yeah, I don't know. I'll do the first one, I guess. Maybe mix them. Trying to color code it so it kind of makes sense. All right, so that would be the one factor. I guess I didn't have enough space, but then we got the other one, right? So what was left over? Well, I got the x first and then the plus 2 second. Boom. And that's it. That's our simplified expression there. Well, factored anyways. And that's a really good question. If this by chance was like a 5 instead of an x, yeah, you could have said, well, you'd have 5 of these x plus 3's and 2 of these x plus 3's. You could have combined those. But since they are not, these factors here, x and 2, are not like terms, that's all that was left. And you could have even factored the x plus 3 and then seen that it would have been 5 plus 2, in which case it would have been 7, but it wasn't. So we had to keep them separated as unlike terms. So another quick tip right here is it doesn't usually give us a polynomial like this. Usually they're going to give us a trinomial, and then we have to split it up into 4 terms ourselves, okay? So even though like we started with this step, and then we saw that you can factor out binomials like this. And then we see with a polynomial like this, it's possible to group them this way, but in the future, they're only going to give us a trinomial, and then we have to factor out, we'll have strategies to do that, but then we got to factor it out ourselves. Sometimes into this format, but there's rules to kind of force it to be this way too. I guess just to demonstrate this, right? So look at the original expression. It was x to the power of 2 plus 3x plus 2x plus 6, like this. If you looked at that original expression, and maybe some of you were thinking this, is you could have said, look at those two like terms. Can't we just combine those? You could have. But at this point, especially with the tools that we have, it wouldn't have done us any good. Okay, so you could have said, well, I changed it into a trinomial. Isn't that simpler? Not right now, it's not. But in the future, I think it will be. Now, I do want you to notice right now, even though we're not going over this specifically, see the 6? What are factors of 6? 3 and 2. Right there, okay? So some of you may have noticed that as well. If you didn't notice that, we're going to go over rules to help you force yourself to, hopefully, to notice that in the future. By the way, it was also 3 and 2 right there, which is important to know too. All right, so we had a little bit of experience. We saw that last one with the polynomial. You guys try this one out. Try this one out. See if you can factor this one by grouping. And yeah, I know it's saying factor out the greatest common factor. It's the same thing. Okay, try this one out. Okay, so and you may have, even organized it a little different in your own way. That's fine. But I'm going to look at each of these terms separately. So I'm going to do the first one in red, kind of like I have been doing. So that's x times y. The second term there, I'm going to show that as a negative 2 times y. Okay, and again, I would be looking for any common factors for all 4 terms first that I can factor out. So let's continue then. So the 10x to the power of 2, the 10 I'm going to split up into 5 times 2. Come on. There we go. And then times x. And then the negative 20, I mean, you could say it's like 4 times 5, but I'm going to break that down even more into negative 2 times 2 times 5, okay? Oh, I should use a different color. There we go. There's the prime factorization of negative 20 now. All right. Well, I don't see any common factors for all 4 terms. It has to be all 4 in order to factor out common factor there, okay? So since I don't see any, I'm going to look to see if there's any factoring by grouping, okay? So I'm going to split these up, and I'll show the plus sign between. And so for the first binomial, looks like we've only got the y's here. Then I'm going to pull these out, and I guess I'll kind of show it like this. Some students may prefer that. And then the first term, I just got these 2 x's right there. Does that look like a face? It's x to the power of 2. And then we got that negative 2 in purple right there, right? So negative 2. Now, since I've got x to the power of 2 minus 2 right here, I kind of expect this one to factor out with, again, I'm just kind of expecting this to end up being in the x to the power of 2 minus 2 right here, okay? Is it going to? Let's find out, all right? So what do we got that's common between them? I got a 5. Oh, we got a 2 as well. Oh, here we got a 5 and the same 2, right? Yeah, there's nothing else to factor out there. So 5 times 2, that would be, I'm going to show it as positive 10. And then what do we have left over in this set of parentheses? You got the 2 x's, that's x to the power of 2. See how it's already starting to match? And then the negative 2 was part of that second term. They do match, x to the power of 2 minus 2, all right? So, at least right now, the greatest common factor is x to the power of 2 minus 2, just by factoring by grouping. And then we also have that y plus 10 there. Okay, now I would look here to see if there's any common factors of either binomial to factor out of either of those parentheses, but I don't see any, so that's just it. And again, if you put the y plus 10 first as the first binomial, it doesn't matter. It's the same thing. Sorry, I guess you could have shown this part right here, right? To get the 10. I don't know, whatever. Okay, so once again, we got a polynomial, 4 terms, And I'll start with the first one. It's just, well, it's just a times b, right? In fact, I'll do it below. And then I would show this as -4, so I'm going to show it as -2 times a times a. Again, I'm continuing through the whole polynomial right now just because I want to make sure that there's no common factors amongst all 4 terms. So the -6 will then become -2 times 3 times b. And then the 24 will be, I guess we may benefit from showing the factor tree here. But I would show that as 6 times 4. Some of you may do 6 times, or 12 times 2. But 6 would be 3 times 2, and then 4 would be 2 times 2. Okay, so there's our prime factorization of 24. And if you need to pull out a factor tree for any of the, especially the larger numbers, then do it, okay? But 24 ends up being 3 times 2 times 2 times 2 times the a. So do I see any common factors for all 4 terms? I do not. Which means that I'm going to go straight into grouping these, okay? Now, like I said before, if you don't have a addition or subtraction symbol between, just put one, usually it's an addition sign. Remember the -6b became -2 times 3, so I have the minus sign accounted for with this -2. So now I'm looking for any common factors from each of the binomials separately, right? So I got this a, which is common with this one. So that means, I don't see any of the common factors there, so I'm just going to yank out an a there. So what's left inside? Well, I got the b from the first term, and then the second term, -2 times 2 is -4, but also the a, the other a that was left over. Okay, so b minus 4a. It's kind of a weird one, but like I said, on the last one, now that I've factored this out and I got b minus 4a, I really expect to see a b minus 4a over here, okay? Otherwise, the factoring thing is just kind of a waste of time. Maybe it still is. All right, so what do I got here? I got, oh, see, right here in this binomial, we got a leading negative on this one. That means that I'm actually gonna give myself a couple negatives over here like this, okay? Because I do want to factor that out as a -2. If I don't do that, here, I'll show you what happens, okay? So let's take that back like, well, I do want that negative. Dang it, come on. I just don't want these ones. There we go. Okay, if I don't do that, then what's going to happen here is I'm going to factor out, and again, I'm doing this kind of wrong on purpose, but there's the 3 threes. There we go. So you could say we're going to factor out 3s. But also, I mean, you could even say 2s, right? And say, well, that's a -1 right there. And that'd be fine. So let's say we factored out a 2 and a 3. 2 times 3 would be +6, right? Well, what do you got left on the inside now is -1b. I'm just going to show that as -b. And then you'd have a positive 2 times 2 is 4, +4, and then the a there as well. So see how they're opposite signs. Positive b minus 4a, positive b -4a. I got -b plus 4a. And whether you notice it here or you notice it here, you need to factor out a negative because this leading, again, this coefficient for this binomial its leading coefficient was negative. Well, we got to yank that out as a negative, okay? So instead of that being a +6, I'm going to treat that as a -6, which is going to change the signs of both terms on the inside of that binomial there, okay? So now it's -4a. Oh, well, that's great, because now they match. And the truth is, you could have yanked out a negative and a -1 out of this parentheses and then changed these two signs to match. We just need these binomials to match, right? Okay, so what do I got left? I got this common factor of b minus 4a to yank out from both terms. And then what do I got left? Well, I had the a here and then the -6. And then I don't see any, again, I'm just checking for any common factors, greatest common factors from either one of those binomials. I don't see any, so that looks like it will do. Right here, same idea for this one, factoring by grouping. Again, I would want to look first at all of the factors of all of them, see if there's a greatest common factor to factor out. And so the first term, x to the power of 3, 1, 2, 3 x's. And then the second term, -6, then I'm going to show that as -2 times 3 then times x. So even as of right now, there's at least x's between these two that are common, but no common values. I mean, you could say there's a phantom 1 there, but common phantom 1s don't do jack squat for us, okay? So don't worry about those. Then we got the negative 5x, so, well, negative 5 times x. And then also the 30, oh, that's kind of a bigger one, right? So let's use a factor tree on that. 30 splits up into, I'll say 6 and 5. You could set 3 and 10, but 5 is prime, and then 6 would be 3 and 2, both of which are prime. So then that becomes, 30 becomes 3 times 2 times 5. Okay, now again, we see from all four terms, there's no like or common factors to factor out from all four. So we're just going to go into factoring by grouping, then see if we can do that. Now, just so you understand, it's possible to not be able to factor anything from these. As far as I can see on the homework, though, every one of them does, but from time to time you could say, well, it can't be factored, and that could happen, okay? And then we got this other set right here, and so I'm going to show some plus between that. Now, notice in green, I got the negative 5x. That means this leading coefficient from this binomial is a negative, so I will be factoring out a negative from that one, okay? Again, that should force the signs to match for us when we start factoring out the binomial, okay? So I got 2x's here and 2x's there. That's all that I have in common from that first binomial. So I'm going to factor out an x to the power of 2. So what's left? In red, I got this x right here. Dropped it. And then in purple, we got the negative 2 times 3, which is negative 6. So when I factor out a negative, and whatever else I got to factor out from this one, I should expect this binomial here to be x minus 6, right? So, I see the 5s here that are common that I can factor out, but like I said, I'm factoring out as a negative 5. It's just if I do that and make that 5 a negative, then I got to make one of these other values negative, so it doesn't change the overall sign, right? Because if you do negative 3 times 2 times negative 5, you still get positive 30, just as you would if you had not changed the signs and made it 3 times 2 times 5, okay? So I am factoring out here a negative 5. That's all that I see that it's in common. And then what do I got left? In green, I got the green x. And then in the orange, I got, really, that's negative 3 times 2, which would be now negative 6. See how that, essentially, by factoring this out as a negative 5, it forced that binomial to match. Well, then what do we got left? Well, you can factor out the x minus 6. And then what are you left with? You got the x to the power of 2 and the negative 5. Boom, there it is. Technically speaking, this could be factored out, but that's for a different class. So this is all we would want to see at this point. So yeah, if you make, instead of the 3 negative, show this as a negative 1 with your negative 5. You could even put this in the calculator. Negative 1 times 3 times 2 times negative 5. It's still 30. Again, it's just shown with, I guess you could call that a phantom 1, what it was before.